Hi everyone, thank you for watching this video. Now in today's part of the lesson, we'll be going through a quick overview on dot diagrams. So what we'll be looking out in dot diagrams, we'll be able to calculate some information such as the range, mean, median and mode of the data, and using it to calculate percentages, and also to use the data for comparison. Alright, now let's begin with our question. Question number 1. The time in minutes taken by 20 patrons at food court to finish their meal is represented by this dot diagram below. Okay, find the range, mean, median, and mode of the data. So first, let's begin with our range. Range is the value of the maximum value minus the minimum value. So in this case, the largest dot is at 28. The maximum value is 28 minutes. Minus away the smallest value, which is down here, the smallest dot is at 15. So this one will be 28 minus 15, 13 minutes. Right, so the range is 13 with a unit minutes for it. Next one, how are we going to find the mean? The average mean, this one, the dot diagram, right? When we're looking for mean, we can actually represent them like a simple table with the data value. So this is all your X data values, and all the number of dots down here will be your frequency. Okay, so in this case, this one, the number for 15 is 1, 16 is 2, and so on and so forth. So now what we are going to do, we are going to calculate the total. So mean is given by summation fx over summation f, which means the data value times the frequency. So if I write it in very long terms, or rather you can do it in your calculator directly, you don't need to be writing the whole long series of working. You will get 15 times 1 plus 16 times, there are 2 dots over here, 16 times 2, plus 17 times 1, plus 18 times, there are 2 dots over here, 18 times 2, plus 20 times 1, 2, 3, 4, 4 dots over here, not enough space, plus 21 times 1, 22 times 2, 23 times 3, no, not correct, 23 times 2 dots, 25 with another 1, 2, 3 dots, plus 26 plus 28. Okay, so this one will be a very long number divided by your total frequency. It was mentioned that there are 20 dots, so the total frequency will be 20. Okay, or alternatively, you can just key everything into your calculator and just write the total sum instead of writing the whole long working. And in this case, I got my total sum to be 420 divided by 20. And that will give me the value of a mean of 21 minutes. Alright, so instead of writing the whole long working, you can just write the total sum over 20 itself. Right, so that is our mean. How are we going to calculate our median? So for median, we are going to look at the median position. So before we calculate the median, we will count the middle position. How do we count the middle position? The middle position is given by n plus 1 over 2. So n is the number of frequency data that we have. So that's total of 20 plus 1 divided by 2. This gives me 10.5, meaning I want the 10th value and the 11th value, the average of these two. So this will be median. Okay, then you'll count the 10th value from the small number. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10th value is 20. The 11th value is 21. I'm going to take an average of these two, which means 20.5 minutes. Okay, so that will be your median. So next one, what do you mean by mode? Mode is the data with the highest frequency, the number that is repeated the most often. So in this case, the mode will be the number. You see this one, 20, has the highest frequency, so the mode will be 20 minutes. Right? Have you gotten the concept for these few parts? Right? So it's important to know all these different data and what they actually represent. For range tells us the spread of a data. So when it comes to range, it's telling you how spread out the data is. The more spread out the data, the larger variation, the less consistent the data. The smaller the spread, the more the consistency there is in the data. The values of mean, median, and mode, these are the average of the central tendency. So they tell us on average, a different kind of averages. Okay, on average, what's the performance of the data in general? All right. Then now let's take a look at the next part of the question. Question says that the management of food court says the average time taken. So this one is talking about averages, right? Am I going to use the range or am I going to use one of the mean, mode, median? Well, this is talking about averages, so probably will be either your mean, mode, or your median, either one. Alright, to finish a meal in 15 minutes, do you approve or disapprove this statement? Now, to better compare it in general on average, the best averages that we usually use, the number one data that we usually use, the most accurate version is usually the mean, unless there are outliers in the mean. If not, the mean will be actually the more accurate comparison average of the data because it involves calculations of all the different values, right? If there is an outlier and then the mean in this case is not accurate because it's affected by extreme values, then the second one that you can always use is to compare the median. This is the more accurate, the next accurate number to tell us an average because it involves arrangement of all the data involved. All right. Then the third one, last but not least, then we use the mode to compare. But usually we try not to use the mode to make comparisons when we have more accurate comparisons such as the mean or even the median. Okay, so in this case, that you take a look at the data, there's no outlier, there's no one value that's totally very far apart from the rest and it's very stands out on its own. So the mean is actually quite an accurate average for this case. So we're going to use the mean. The mean in this case is 21 minutes. They say that the average time is 15 minutes. So they say something lesser. Do you actually agree with the statement? So now when the question say explain, you need to give evidence, then you make a conclusion. So in this case, the evidence that I'm going to use will be the mean. So since the mean time, mean time is 21 minutes, longer, which is longer than 15 minutes. Therefore, this statement is not true. Do you disapprove of this statement? Okay, so usually when we have this kind of questions where we need to explain, we always need to quote certain value and the numbers. Don't be lazy, write the numbers itself and usually we'll compare it. So you give an evidence and then you write with your conclusion over here. Alright, so always give the evidence, numerical numbers to back up your answers. Okay, we are moving on to the next part of the question. Okay, up next in this question here, we are actually looking at a back-to-back dot diagram. What does a back-to-back dot diagram means? The back-to-back dot diagrams uses the same set of number line for all the data values that is given over here, but it gives you two different sets of data. The row above, okay, is representing the male and the row below will be representing the female. The dots, the smallest number will start from the dot at the bottom. Alright, well this one is nearest to the number line. Okay, so in this case, usually for this kind of data, we will need to do a comparison of data between, in this case, is the male and the female data. So let's read through the questions and begin with the calculations. There is exactly same 20 groups of male, 20 female students, and all these masses are in kilograms. So first one, find the median mass for males. So I'm going to find the median. Median, since it says that there are 20 male, before we find the median, we must find the middle position. How do we find the middle position? We take the total frequency, which is 20 males, plus 1 divided by 2. This gives me 10.5, meaning that I take the 10th value and the 11th value and add them together. So counting from the smallest data, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is 58. 11 value also 58. So it means this is 58 plus 58 divided by 2. Still we get 58. This is talking about masses, so there's a units in kilogram, kg. So we have 58 kg for median of males. Alright, next one, find the molar mass for the female. Molar mass actually means the one with the highest frequency, the number that is repeated the most often. So you can see that this value, data value here, 56, is the one that's repeated the most often. So the molar for female, molar mass will be equals to 56 kg. The question now says that 25% of the students were overweight. Is it just the male or is it just the female? Well, it's talking about students. So there are 20 male and 20 female. How many are there in total? There will be 40 students in total, and we want 25% of them who are overweight. So let's look at the 25% of 40 students. And that gives you 10 students. Alright? But now these 10 students represent 10 dots. They say that they are overweight. If they are overweight, do they belong to the smaller data value or do they belong to the larger data value? They belong to larger data value. So if it's larger or larger than a particular weight for it to be considered overweight. So I'm going to count from the larger number and 10 students in total. So I'm going to look at my axis over here and count from the back. I want 10 students from the larger number. So this is 1, 2, 3, 4, 5, 6, 7, 8, including the female, 9, and 10. So our 10 students were cut off at the number 60. If I have anything lesser than 60, they do not belong to this 25%. So actually the minimum weight for them to be considered overweight will now be the number 60. So in this case, our minimum weight will be 60. Have you gotten the concept? So remember, you're talking about students, so total students, and count from the tail end, the other end. Alright, next one, we are going to calculate the mean mass for female students. Now, like we were saying, to find mean mass, we need to find the summation, mean summation fx over summation f. So in this case, I do not want to write so much of a word, okay? So what are we going to do? We're going to calculate for mean mass for female. So we're just going to use my calculator directly. Female data. So let's take a look at our female data. We have 1, 2, 3, 46 times 3 plus the next data set 47 one time plus this number is 49 plus 50 has a frequency of 2, 50 times 2 plus 51 has a frequency of 3 plus 52 one time plus This number is 55 with a frequency of 2, and 56, 1, 2, 3, 4, plus 57 plus 59, and 1 unit of 60. So I got my total to be 1049, the total mass. So my total mass will be 1049 for the female. Divide by my total frequency. We know that there's a total of 20 females here. Okay, so divide by 20, that will give me a number of 52.45. This number is exact. Do not round it off to 3 significant figures. Okay, sometimes we can also even give fractional value for the exact value. Okay, for students who are in Sec 4, you know how to use the calculator to calculate your statistics. You can use the statistics modes to calculate the mean. Just key in the data part by part and the frequency. Alright, if not for students in lower Sec, then you probably need to do the working. Okay, so this is the mean mass for the female. Let's take a look at the next part of the question. Find the range for the males. So when we are talking about range is the maximum value minus the minimum value. This is the range for the male. Right, let's take a look at the range for the male. My largest data is the number 69. My smallest data for the male is 52. So 69 minus 52 kg. Alright, and that will give me 17 kg. Okay, so now we have a couple of different data, so many data available. The question now gives us in the next part that the mean mass for the male. So if they gave you the mean is 59.325, they calculate the mean for the male. Write down 2 comments comparing the masses of male and female students. If they want me to have 2 comments, meaning I will need to compare 2 different data. Now, what are the 2 data usually that we are going to compare? 2 areas that we are usually compare. Number 1, we usually compare averages, the average performance or whichever. So in this case, we know the mean, so we're going to use the mean to do our comparison. The second one that we are going to compare is usually on spread of the data. So in this case, in Sec 2 syllabus, we have not learned interquartile range yet. So we'll just be using range for comparison of the data, the spread of the data, which data is more widespread. So now let's begin with the first one to compare the average, which is we're going to use the Bettel measure of central tendency. That will be the mean. So first, let's give evidence. So since we have the female is 52 kg, the mean for the male is 59 kg. What will you want to write? You can say that the females weigh lighter, or you can say that the male weigh heavier. It means the same thing. So now if let's say I'm going to write that the male weighs heavier, so my evidence should prove my theory. So I'll say since the mean mass for male is equals to 59.325 kg, greater than or larger than the mean for my female, which is the value 52.45 kg. Okay, remember, give the data value, compare, give the data value. Since this is true like that, in this case, male is heavier than female. Therefore, then we write the conclusion, males are heavier. Okay, so this is the first comparison we have on average. The second comparison we'll be looking at the range. Well, I've calculated the range for male. Have I calculated the range for female? So in that case, I need to calculate the range for female. My largest female data is 60, smallest is 46. So I'm going to calculate the range for female. range for female is made up of 60 minus 46, which is 14 kg. And you notice that this is actually smaller, right? Smaller than the range of male, which is 17 kg. Therefore, the mass of females has a smaller spread. Spread of the data. So this is talking about the range, giving the units, the value, compare, and this is talking about spread of a data. So now we have write down the comments for comparing male and female students. Okay, have you gotten the concept? With that, I shall end off for this part of the lesson. I'll see you for the next lesson. Bye bye.